Hi, I'm Geoff Wade, Senior Network Engineer at ServiceNow. That means I do a little bit of everything, whether it be design review, network deployments, operations, etc. If it pertains to connectivity or to or within ServiceNow. Thanks to our Chandler team for inviting me up here. Today we're going to talk a little bit about measuring and troubleshooting the performance of global data centers at ServiceNow. So who is ServiceNow? ServiceNow offers everything as a service cloud computing, including platform as a service enterprise service management, software for human resources, law, facilities management, finance, marketing, and operations. We specialize in IT service management, IT operations management, and IT business management applications. And we provide forms-based workflow application development. We have integration options for several platforms. So how do we do that? Well, we're a cloud provider, which means all of our customers reach us in the cloud. And because we're a cloud provider, we must have full redundancy. That means that we have two-end infrastructure across all our data centers. We have independent duplicate architecture at physically mirrored locations for each physical data center to ensure fault tolerance. We have good data centers. All data centers are Tier 3 plus. The infrastructure in those data centers can effectively prevent any equipment failures or have zero downtime for equipment failures for anybody in any service in that data center. We have enterprise class infrastructure and operations. And while all of that helps our cloud environment to stay up, we also need to monitor this environment so that if problems occur, we know about them, we can isolate them, and we can fix them, often before our customers ever realize there's an issue. So why does ServiceNow use ThousandEyes? Back in 2012, we grew beyond letting other companies manage our data centers, and we started building our own. That meant we also had to monitor them. Several of us were familiar with the ThousandEyes product, and we began using it for external monitoring. And since then, we've expanded greatly. And when you're worldwide, you need a world view. The global footprint is why we considered ThousandEyes. That, combined with the feature set, is why we selected ThousandEyes and why we continue to use it today. Because all of this redundancy and duplication doesn't matter if customers can't reach you. So knowing when some customers can't reach you is crucial for fixing things before it becomes a major crisis. And so let's talk a little bit about what happens if we are down for an hour. What happens if we can't fix it? Well, in 1 hour, our customers compute 450,000 performance analytics scores. They add 20,000 assets. They add 95,000 configuration items. They send 68,000 notifications. There's 3,000 change requests that don't happen. There's 3,000 live feed messages that don't happen. And there's 2,000 workflow activities. There's 9 different global development locations that essentially stop. There's 450 copies of ServiceNow for quality engineering testing that don't happen. There's 63,000 automated engineering tests that don't happen. And on our infrastructure, there's 24 billion database requests and 105 terabytes of backups that don't happen, plus the other stuff that you see there. And unhappy customers, of course, quickly result in no customers. So remember that to many of our customers, because we're a cloud provider, we are the internet. So we can't just get away with saying, the internet's broken, try again tomorrow. So some big benefits of ThousandEyes that we see are views from anywhere reasonable in the world. And I mention reasonable only because we don't really need monitoring of our data centers from Antarctica or outer Mongolia. ThousandEyes is flexible. We don't want to have every ThousandEyes node run every available test to every bit in each of our data centers. Think of the noise that would generate, and we don't usually care if every node in Tokyo and Singapore can reach our Brazil data centers, for example. There are multiple types of tests, each with their own configuration parameters, and we'll talk a little bit more about that in a minute. And there's different roles, different logins that we can use. One second. There we go. So there's different logins that we can use. We love the ability to have different logins that show only the information that a given group needs to see. Let's take this example of the dashboard that our SRE, or Operations Centers, use. SRE, of course, is the eyes, ears, and often the steel nerves of our infrastructure. All the input from all the monitoring tools lands at their feet, and they have to process it, or they risk missing downtime. So because of that, logging into multiple screens in a given tool doesn't work. But ThousandEyes provides a single-page dashboard to quickly show immediate alerts. That same page also shows some normal statistics, useful, also shows normal statistics, useful in case the SRE needs to see what a green light looks like as opposed to a red light. This page that you see here is on display full-time in our operations center, and SRE can easily drill down if something shows red. The dashboard is also easily configurable in case more or fewer tests are needed at that point. We also use email alerts in an operational capacity, and those go to a wider audience. And why do we do that? Well, there's a couple of reasons. First of all, it backs up the GUI alerting. If somebody goes for a coffee break, whatever the case may be, an alert gets missed, at least they can come back. They will see the alert, but there's also an email so that other people can act if that person cannot. The email alerts also show, or can show, either a single issue on the internet, or, as seen here, we can see that when we compile them, they can show a trend. Anyone see the trend here? Offhand? It's probably, the print's too small. So, so every morning Pacific time, which was evening prime time local, we see packet loss to our ISP interface addresses in 2 sites, all via a specific vendor. Well, our customers never told us because it's not broken. There's no actual downtime here happening yet. But with this, we know that it's time to contact that provider and open a ticket and say, hey, you're probably experiencing some congestion. Maybe it's time to fix that before our customers start telling us that it's time to fix that. SRE can use all the data that they have to help pinpoint an issue before they escalate it. So there's a lot of examples here. We have an ICMP reachability test, and that's also usually used by SRE, but we can correlate a lot of the data we receive from that, such as if this data shows a site VIP is unreachable, but one node via one ingress ISP path, and no other monitoring tools are alerting, no other alerts are happening, there's no BGP down, there's no customer connection count drops that happen suddenly, all our customer VPN tunnels stay up. Then SRE knows it's likely just an external issue. They can identify that when escalating. They can say, hey, we see this one path is failing, and we can take appropriate action. If this data shows that a site VIP is unreachable for several nodes, from several nodes, via one ingress ISP path, and no other monitoring is triggered again, SRE knows that it might be an ISP maintenance. There's a specific ISP problem, and they can notify us. They can tell us that when they're escalating. If this shows that a site VIP is unreachable from all nodes configured, and yet there's still no BGP down, but internal site resources are reachable from the site pair, from the pair site, I should say, we'll probably look at an application delivery controller issue at that point. But that has we can correlate that with some of the other data that we're going to talk about in a minute. And if this data shows that a site VIP is unreachable from all nodes configured, somehow there's still no alerts down, and we see a lot of internal site resources affected, then, well, it's probably a full site outage, and that has a very different escalation path. There's probably a lot of people yelling fire at that point. We also use ThousandEyes for a very basic TCP image load from our application delivery controllers. So first, in most cases, the TCP image load should fail from the same nodes where ICMP becomes unreachable. That makes sense. But if ThousandEyes shows that site VIP is reachable via ICMP, then from all nodes configured, and yet TCP image loading fails, it pretty much points us directly to an application delivery controller issue or an upper layer issue is the first thing to check. Sometimes at that point, it's not all about ICMP. We also have a few very important pages that we test. Mostly it's pages that customers use to reach us, to tell us that they're having a problem, ticketing and support, things like that. Those require more specific and more advanced tests. So some of those pages might share an IP address though. So ICMP reachability isn't reliable for that specific page. And some of those pages might require upper level login testing or some whatever upper layer testing that we need to test. And having ThousandEyes test those things quickly identifies a problem that our customers would see with us. Even if their service is not fully down, there may be a support case or something like that that's failing. A simple image load isn't enough to test that at that point. But that level of testing isn't needed for every test that we do. So think of all the noise that would be generated if we did that for every test. Besides SRE, our other groups might use ThousandEyes for different reasons, oftentimes to help pinpoint a problem. Pinpoint another problem. For example, we have systems engineering groups that use it for mail monitoring. That can pretty quickly tell us from the outside, from the customer view, when mail isn't working as expected. Now, we might also monitor our own mail queues. That kind of makes sense. But that tells us when we have a problem inside going out. The only other way we can really test outside coming in is to monitor our customer mail queues. But something tells me that our customers don't want us on their mail servers monitoring their mail queues. And we could also just wait till they tell us there's a problem, but that's bad customer service in general. Network engineers like me love the BGP prefix testing and route visualization. It helps us quickly see a problem from a part of the internet to us, and we can replay what happened in a given time frame so that we can provide an RFO to customers, for example. Now, let's talk a little bit about that BGP route visualization. A little bit about our network that matters here just for context. Our customers are primarily region specific. We have a site pair in a given region, and a customer is typically tied to that site pair. That means that right now, we only have to announce our network space via BGP for those two sites, from each of those two sites. We don't need to announce every prefix out every data center that we have. That also means that up until now, we didn't need a backbone. We could isolate our monitoring tools accordingly. We could only have specific tests monitoring from specific nodes to specific data center pairs. Again, we don't care much if our Tokyo sites, we don't care much, we don't care much if our if Tokyo can reach our Miami site, and the path between those areas can be long and problematic, again, adding to noise levels. ThousandEyes provides us, lets us provide that monitoring isolation for the Miami site and its pair sites so that only ThousandEyes nodes close to where our Miami customers are can be used. That way, not having many very remote sites, very remote nodes cuts down on the false positives. For example, here, and you can see this as I page back and forth, that the top of the page shows a highlighted timeline, while the bottom shows what's happening in that given timeline here. So what you can see via this replay feature, this helps us do diagnostics during an event if it's still going on. But for short-term events, it's usually more useful when doing forensics immediately after the event. And an added bonus is that it makes RFO explanations to our managers and to our customers much easier. Sometimes we can just show them an image, and it really helps. But one of the big problems with similar tools is that they only show a limited number of AS hops away from you. And thank you for demonstrating this previously, but we can see here again via the timeline that sometimes one hop away isn't, sometimes one hop away isn't actually as beneficial as looking at farther away to see where the problem was. By increasing the number of hops, we can see that it's often, a problem farther away, and sometimes we have to educate our own ISP about their problem. May not be our problem, may not be our customer's problem. If it's an ISP problem, they may not even know about it. We also like that ThousandEyes external nodes get their data primarily from publicly accessible route servers. That helps us verify what ThousandEyes sees as well, and we can honestly spend a fortune in time logging into many different route servers to gather that data. But why would you spend all that time, greatly delay the mean time to repair, greatly complicate the RFO analysis when you can easily see an aggregate of that data in a quick visual format? And even then, with the number of hops expanded, the replay feature still works to show changes across a given timeline. I did not show the top of the page here just due to space, but as you can see, things change. Even then, this can be too much data being visualized, when sometimes you just want to see the problem. And ThousandEyes lets us do that too. You can focus only on the ThousandEyes nodes that saw an issue, as well as only the links that saw an issue. There's also a link to other tests that might be related. For example, we originate a couple of different prefixes out of this data center via BGP to our upstream. So why would it be useful to have different tests for different prefixes? Well, let's say we see a problem with only one of our prefix announcements. This gives us data to use if we have to troubleshoot. And in this case, we might have to escalate to a particular upstream provider to ask why, if a path changed to a specific ingress path that uses that provider, and ThousandEyes saw the path to that prefix suddenly stop. Well, maybe the provider's just broken. That's certainly possible. And it's only affecting one prefix. We used to see that more in the olden days when Cisco set tables would suddenly lose a prefix or something like that. More likely today, though, that provider's pure prefix filter isn't up to date, and they're not accepting or propagating our prefix. So when the path changed to use that provider, it causes an outage for our customers until the provider fixes it, or we move back to the other path. So, in summary, ThousandEyes provides an excellent view into your network. You can use it with many different groups, but especially network intent. It allows specific monitoring of what we need without a lot of extra noise. It helps us isolate and determine the urgency of an event during the event, and therefore reduce mean time to repair. It helps us figure out what happened after the event, which again is very useful when managers are asking or customers are asking, and we can quickly tell them. For the future, there's a couple of things that we're looking at ThousandEyes for. We're in the beginning stages of evaluating the Internet Outage Detection tool, which would let us use ThousandEyes aggregated data to actively notify us when they think there's a bigger problem on the internet than just the one we see in alerts reaching our own world. And that way, if we see alerts from a given set of nodes to our site VIP at the same time that many others are also receiving similar alerts, then we can safely say it's not us, and we avoid a big fire drill, and then we can do some later, slower forensics using BGP prefix and route tests and replay. Part of our evaluation for that will be data sanctity, data privacy, both for our own data and for other customers' data. And remember, sure, our customers might think of us as the internet, but it helps if you can mention that even if there's a path between us, even if it's the path between us that's the problem, that we still see the problem. Another thing that we would like to see from ThousandEyes is metrics for downtime. For example, how often did ThousandEyes have a problem, let's say packet loss over 20%, reaching our service via a given ISP in the last 60 days? We use this data primarily for during capacity augmentation or contract renegotiation. One thing that we network engineers like is we can use it as data to overrule any preconceived notions about an ISP. And because our ThousandEyes monitoring setup is mostly segregated per region, we could use this data to quickly identify the problematic ISPs we use for that given region. Sometimes an ISP is great everywhere except one place, and it's helpful to know that one place, and so we can avoid them at that point. Another thing that we considered doing a long time ago, and we're actually looking into it again at this point, is using the ThousandEyes offering for putting internal nodes in your network and doing cross-site monitoring, both of your private network and across the internet. Initially, we didn't do that because, from a business sense, we already had several other monitoring platforms in place that test our infrastructure from the inside. So ThousandEyes was most useful from the outside at that point. But even if we wind up not using that via ThousandEyes, it's great to know that we definitely could. So thank you for listening.